Assalamu alaikum dear students, class 11 टॉपिक। आज का मेन टॉपिक जो है दैट इज फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स। लेकिन फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स से पहले जो हमने टॉपिक्स डिस्कस किए यहाँ पे वो है वर्क, इंटरनल एनर्जी नंबर फर्स्ट दैट्स वर्क, नंबर सेकंड इंटरनल एनर्जी। But before going through the topic that is the first law of thermodynamics, we should first know what is heat. को नंबर थर्ड जो आज हमें पढ़ना है यहाँ पर पहले heat, उसके बाद हम डिस्कस करने जा रहे हैं that is the first law of thermodynamics. वर्क के बारे में हमने पढ़ा है कि वर्क जो है that is a form of energy which is transferred between the system and the surrounding is due to pressure difference. वहाँ पर हमने डिराइव की थी इक्वेशन that is W is equal to minus P del V for work of expansion and for work of compression. This is for work of expansion and work of compression के लिए क्या है कि that is W is equal to P del V. This is regarding the work. Now second जो हमने टॉपिक डिस्कस किया था यहाँ पे that is the internal energy. Internal energy जो है that is the sum total of various, that is the first. Second, that is the internal energy which is the sum total of various types of energy stored in a substance, or the stored amount of energy in a substance or in a system, that is called as the internal energy. And that internal energy that is denoted by E or that is denoted by U, that is called the E kinetic energy plus E potential energy plus nuclear energy, chemical bond energy plus E rotational, E vibrational, E translational, etc. और ये दो चीज़ें हमने डिस्कस की इन द प्रीवियस वीडियो लेक्चर्स. आज का जो टॉपिक है दैट्स फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स. लेकिन फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स पढ़ने से पहले हमें पता होना चाहिए व्हाट इज हीट. सो आवर द टॉपिक हियर इज फर्स्ट, द टॉपिक इज दैट इज heat. What is heat? Heat is also a form of energy which is transferred between the system and the surroundings due to temperature difference, that is called as the heat. So we have heat here. Heat, that is it is the transfer. What is the energy which is transferred between the, it is the energy which is transferred between the system and the surroundings due to temperature difference. So we have heat energy. Heat is basically it is a form of energy which is transferred between the system and the surroundings due to temperature difference. जहाँ पर temperature difference होता है वहाँ पर energy transfer होता है between the system and the surroundings. That energy is called as the heat which is transferred due to temperature difference. इसमें आपको याद रखना है कि temperature difference should be there, then there is energy transfer between the, then heat is transferred between the system and the surroundings, that's called as the heat. Now if the heat is given by the system to the surroundings, it is given as a negative sign, and if the heat is absorbed by the system from the surroundings, it is given as a positive sign. Number first इसमें हम डिस्कस करेंगे नंबर फर्स्ट पॉइंट हीट में, that is if the energy, if the heat is given by the system to the surroundings, it is given a negative sign. When heat is given by the system to the surroundings, then heat is given as a negative sign. And if the heat is absorbed by the system from the surroundings, it is given as the positive sign. So it is given as if heat is absorbed by the system. Second point, if heat is absorbed by the system from the surroundings, it is given a positive sign. Now the units of the heat. Heat, its unit is joule per Kelvin or it is joule per centigrade. Its unit is SI unit is joule per Kelvin. Units of heat. It is first, either it is joule per degree centigrade or it is joule per Kelvin. So we have the first topic in our today's video lecture, that is the heat. What is heat? Heat is basically an energy which is transferred between the system and the surroundings due to temperature difference. Temperature difference should be there. Then there is energy transfer. Heat is transferred between the system and the surroundings. Now, if the heat is given by the system to the surroundings, it is given as a negative sign, and if it's absorbed by the system from the surroundings, it is given a positive sign. Now we have the units. Unit is joule per Kelvin or joule per centigrade. Now our main today's topic is first law of thermodynamics. What is the statement of first law of thermodynamics? So topic is first law of thermodynamics. First law of thermodynamics is called as a law of conservation of energy. It states that energy can be neither created nor destroyed. However, it can be transferred from one system to another, from one body to another, or from one system to another. That's called as the first law of thermodynamics, which states that total energy of the universe is constant. It can be neither created nor destroyed. First law of thermodynamics, it states that total energy of the universe is constant. It can neither be created nor destroyed. However, transferred from one form to another. How it can be transferred from one form to another form, or from one system to another system, because every system has its internal energy. So it is the energy which is stored in the system which can be transferred from one particular system to another. So we have the first of thermodynamics. It states that the total energy of the universe is constant. उसको हम न create कर सकते हैं न destroy कर सकते हैं, लेकिन हम इसको transfer कर सकते हैं from one form to another form. That's called as the first law of thermodynamics. It's also called as law of conservation of energy. Now we have the mathematical formulation of first law of thermodynamics. This is the statement of first law of thermodynamics, which is energy can neither be created nor destroyed, however transferred from one form to another form. That's called as the first law. That's the statement of the first law of thermodynamics. Now we have the mathematical formulation of first law of thermodynamics. Mathematical formulation of mathematical formulation of first law of thermodynamics. First law of thermodynamics. This first law of thermodynamics, it gives us basically the relationship between the internal energy, work and heat. It gives us first law of thermodynamics gives us the relationship between number 1 internal energy, number 2 work, number 3 heat. Now suppose we have a system A and it has its particular internal energy, that's what the E1, because every substance or every system is associated with a certain definite amount of energy, or the energy is stored in a particular or in any particular system. That energy is called its internal energy. And if we have, suppose we have a system A and its internal energy is E1. Now its internal energy can be increased by two ways. Number first, by giving heat to the system or by doing work on the system. Then the internal energy of this particular system, it can be increased. So internal energy of the system, suppose we have a system A, we are going to increase its internal energy, and it is own internal energy is equal to E1. So we are going to increase its internal energy. We have the system A, its internal energy is E1, and we are going to increase its internal energy. So its internal energy can be increased by two ways. Number first, by giving heat. If we supply heat to the system, its internal energy, it becomes E1 plus Q. And if we are doing the work on the system W, then its internal energy, it will become as E1 plus Q plus W. And let this internal energy of our final, this is our initial state, A is our initial state, and suppose this B or this C is our final state. Its internal energy is E1 plus Q plus W, and let that is equal to E2. So we have the initial system whose internal energy is E1, and if we are going to increase its internal energy can be increased by two ways: by supplying heat to the system or by doing work on the system. If we give heat to the system, its internal energy will become E1 plus Q, and if we are doing the work on the system, then its internal energy will become E1 plus Q plus W, and let that internal energy be equal to E2. So we have the relationship here as the total internal energy of the final system, that's our C system, is equal to E2. E2, that is equal to E1 plus Q plus W. We have nothing to do here. We simply say that we have a system A, इसकी internal energy जो है किसके बराबर है, E1 के बराबर. अब हम इसकी internal energy को increase कर सकते हैं. कैसे? By supplying heat to the system. So its internal energy become E1 plus Q. And if we do work on the system, then its internal energy will become E1 plus Q plus W. And at this amount of energy is equal to E2. So we have here the equation first. That's we have E2 is equal to E1 plus Q plus W. अब हम क्या करेंगे, इसको यहाँ लाएंगे, E1 को यहाँ लाएंगे, so it become E2 minus E1 is equal to Q plus W. What is this? E2 minus E1, it is the internal energy change, that is internal energy of the final state minus internal energy of the initial state, that is given as del E is equal to Q plus W. where del E is the internal energy change, where del E is equal to change in internal energy, and Q, that is the heat. Q is equal to heat and W is equal to work. Now we have this is the mathematical formulation of the first law of thermodynamics, where we have a relationship between the internal energy change, that's heat, and the work. This is mathematical formulation of the first law of thermodynamics. Now we have some special cases regarding the mathematical formulation of the first law of thermodynamics, regarding the first law of thermodynamics. Some special cases. We have some special cases here. Special cases. Special case. Number first special case is that if we have an isothermal process, for isothermal processes we have the internal energy जो है, that is the function of temperature, and if we kept temperature constant, there is no change in the internal energy, there is no change in the internal energy, that is the del E, it becomes equal to 0. So we have 0 is equal to Q plus W, or the Q is equal to minus W. For isothermal processes where temperature is constant and जो internal energy है, that's the function of temperature. If you are doing keeping the temperature constant, there is no change in the internal energy, and del E जो है, that is equal to 0. That is equal to 0. So we have here 0 is equal to Q plus W, or Q is equal to minus W. This is the first special case, that is for isothermal processes we have the internal energy change that's equal to 0 and Q is equal to minus W. Number second, for the isochoric or isochoric processes. Number second case जो है for isochoric processes. Isochoric process में क्या होता है कि डेल्टा V जो है, that is equal to 0, change in the volume, that is equal to the 0. So we have here first law of thermodynamics, that is we have E is equal, delta E is equal to Q plus W. And for work of expansion जहाँ हमारे पास है equation, that's for work of expansion. Work of expansion के लिए क्या है, that is W is equal to minus P del V. For work of expansion we have W is equal to minus P del V. So हम इसका वैल्यू यहाँ पर सब्स्टिट्यूट करेंगे, that is delta E is equal to Q minus P del V. And for isochoric processes del V किसके बराबर है, 0 के बराबर है. So we have delta E is equal to Q. This is the second special case regarding the first law of thermodynamics ने derive किया. Number third जो है for isobaric processes where pressure is kept constant, we have equation for isobaric processes. Number third case जो है for isobaric processes. For isobaric processes pressure जो है, that is constant. So we have here according to first law of thermodynamics delta E is equal to Q plus W, and for work of expansion we have W is equal to minus P del V. So we have delta E is equal to, here we have Q minus P del V. The pressure is constant, so for the isobaric processes delta E is equal to Q minus P del V. This is the third important case regarding the first law of thermodynamics. So we have, in today's topic, we have the first one, we have the heat. What is the definition of the heat? It is basically the energy which is transferred between the system and surroundings due to temperature difference. Now we have this important topic, that's first law of thermodynamics. First law of thermodynamics is also called as law of conservation of energy, which states that the total energy जो है universe की वो है constant. It can neither be created nor it can be destroyed. However, it can be transferred from one form to another form. Then we have the mathematical formulation of the first law of thermodynamics, where we have a relationship. We obtain that relationship between the internal energy change and the pressure volume work done, that is delta E is equal to Q plus W. Then we have some special cases regarding the first law of thermodynamics, or the mathematical formulation of first law of thermodynamics. For thermal processes, we have the temperature that's constant, so there is no change in the internal energy. And then we have Q is equal to, first जो है Q किसके बराबर है, माइनस W के बराबर. For isothermal processes, now for the isobaric processes, where change in the volume, that's called 0, and delta E is equal to Q. And for isobaric process, pressure remains constant, so we have delta E is equal to Q plus W. For work of expansion, we have the equation, that is W is equal to minus P del V. So हमने substitute किया. Finally, we obtain the expression, that is delta E is equal to Q minus P del V for isobaric processes. This was all about the first law of thermodynamics. In the next video lecture, we will discuss enthalpy and enthalpy change. Thank you so much.